This is the second video of our CAM station project. In the first part, we went through why we're building it, how to model and make drawings in Fusion 360, as well as the seal fabrication and CNC routing. You can head back and watch that now. I'll put a card above. If you need to start fresh with Fusion, we also have a series on learning Fusion 360. I'll put a card here and link below so you can check that out. Alright, let's get into Fusion 360. We're going to start setting up the CAM for our tabletop here. So in this file, we're in the manufacturing workspace. To get just this piece out of here, I actually did a thing called Derive. So if I go back to the original file here, do S for search, and I type in Derive, what Derive allows you to do is take any component, or I think any body too, select that thing you want to take out of the model and make its own separate thing. This is nice for iterative design where maybe you want to change some stuff in the design model for like this presentation for YouTube, but you don't want your CAM to change in relationship to that. So multiple people can also work on this file, which is nice. So somebody's working on the bottom and they happen to save something, it's not going to mess up the CAM file without choosing to update that file. So anyway, Derive allows you to quickly do that. So Derive, I've selected the body I want, which is just this top. When I click OK, it's going to create a new file with just that in it. And none of the design features are there, so you can see it says Derive from CAM Station. It's nice to just have that one thing in here. It keeps the file light and very specific. So that's what this CAM file is. You see the same thing. I did a little sketch because I wanted to center. The stock had these metal strips in it, which is the IKEA top, and I think it was just for stabilization of the wood. But I obviously didn't want to hit those steel strips, and I didn't want those to come out the edges anywhere, so I drew that out pretty accurately. So I knew exactly where they were going to run through, and then went back to manufacturing, and I set up that file. To go through the CAM quick, first thing you do on any CAM file, you need to set up, so click New Setup, and you would select your body, which has been done already. And then I would select size, which was, I believe, 61 by 30 by, not that, but maybe 1.125. And I wanted it to be centered in the stock. So that's what this setup is. If I go in and look at that, you can see the stock was already, it was modeled from, I drew the actual stock as a body itself. So I selected that body, and that gave me these dimensions, which were my accurate measurements. Chose my design piece as the body for the setup. First thing I wanted to do was face it, since unfortunately it was not flat at all coming from IKEA. I guess that's what you get for $100. It's really nice, kind of solid glue up otherwise, but we really can't make this top for under $100 material. That's crazy. I can't pay somebody, or unless I don't count my time. It's not possible. So I wanted to face it, make it flat. I use our shear hog, just had it face the entire thing back and forth. 12,500 RPMs, 260 inches a minute. Somewhere around 300 is where we've been sitting, unless it's lighter passes, but this was just a quick thing, so I didn't want to push it too hard. So 12,500, 260 inches a minute. Multiple step downs are important here because, you don't want to face way too much material. So I think I did 120 here. I think it did 2 passes. I don't think it needed to do 2 passes, but you would get a nicer surface finish that way. And I did those passes with the grain. That usually is a little nicer. That's about it. You just don't want to lead in too heavy. So that's what that pass looks like. And it took quite a bit longer than I wanted to because it did do 2 step downs. I would have definitely taken that out the second time. We don't need 2. The next step was to trace that meat juice slot all the way around. So I drew a line exactly where I wanted it. I believe back here in sketches, in design, and you can see that sketch there. I projected those lines in, so then you can trace it exactly where you want it, and that could be at the top there, and you can offset it axially up and down in the trace operation. So it's centered, and then our ball mill, using the trace operation, which is here, we'll just follow that line, and I had it go 16,000 RPMs, 100 inches a minute. It can go a little faster than that, but it is a very large 2-inch cove. I'll include that here. and selected all those curves manually so that they're all going the same direction all the way around. Heights are usually pretty fine on their own for trace. And then what I did here, which I should have adjusted, I just didn't go back in and do it after I cut it, was we could have gone deeper here. And that was, I was trying to match my design, and I think it should have been more, maybe double that, maybe 35 instead of 20. But that just wasn't enough depth. And that axial offset is shifting up and down the spindle axis. So up and down this way. Would have made a little deeper cut. I think it would have been more effective, but that's what that looks like. If you didn't know, when you're simulating, you can click the left mouse button, drag it back and forth, and you can control exactly where each point is very finely. Next up, we did some 3D adaptive pockets to clear out these holes. We used a vortex. Let's see what tool it is. Still getting used to this new tool selection window. Don't really love it. There's a lot missing from the old. And I believe that is the Vortex 1440, which is a roughing tool. Well, semi-roughing. It would produce a finished cut, but it does have a serrated edge. But that serrated edge will help break up chips, especially in hardwood, reduces harmonics, and makes a really nice cut. Usually you can use that as a finishing cut too, which is nice. So that's a 3/8 inch tool. Vortex tools are phenomenal and can go probably faster than this. It's 280 inches a minute, 18,000 RPMs. The max roughing step down was 3/8. You could probably go a little bit more, but it's just kind of a nice, if you can't do a hem operation, you don't want to go too crazy with your slotting. Did a radial stock to leave of 25 thou, and then the axial was 20. Just to give us a little something to clean up with a finishing tool. You do climb cuts on roughing operations, typically on wood, hardwood or solid wood like this. So there's that pocket. Then we did the same tool as a 2D contour here. Rough cut, 17,000 RPMs, 280 inches a minute. Stock to leave of 50 thou on the radial, 10 on the axial. When I select the chain, just kind of up here, but make sure your heights are selected to stock bottom and stock top. Ramp down in at 25 degrees, and you want to ramp with an entry point going with the grain in all woods. Otherwise, you're going to get tear out. The wood will splinter. Contour select on the outside, set to the stock bottom. And then as a finishing pass, I used a 3/8 inch compression cutter. Is a 3430 Vortex, which also has a serrated edge for chip breaking, which is really good for hardwoods and plywoods, and it just helps reduce heat because you're moving smaller chips around and the chip ends up being your heat sink, so it's better all around. Usually creates a really nice clean edge, as it did here. Did that as a cleanup because these had stock to leave too. So cleaned up these holes on the inside first. Not sure why I did two operations there, but the stock bottom has to be a little bit deeper. Duplicated that as a 2D operation as well. On the outside, same thing. On these cleanup passes with almost all tools, we do a conventional milling. Ends up being a nicer finish pass on wood most of the time. Same thing, entry on the outside, ramp. Feed rate's a little higher. Did 18,500 RPMs at 300 inches a minute. Probably could go faster. Heights also 10 thou below the bottom of the stock. Go through and simulate that. Select the top up here. Simulate. First thing we're going to go through, obviously, is the facing. And then we did this ball mill, which looks way cooler than it ended up being, but it's a big, nice tool that's fun to use. This is one of the benefits of Fusion, is you get really nice, accurate previews right inside the manufacturing space. Roughing tool. I highly recommend simulating everything you set up on the CNC. There's really no reason to skip it unless you, for some reason, have a gun to your head. There's your little cleanup. It's kind of imperceptible, but it is cutting. I think I did a double pass or an overlap so that the ramp would get cut twice. I think I did them twice on the inside there. Those came out really nice and clean. So it did both of those. Now we're going to do the finished pass on the outside. and in warp speed, of course. You can see that stock to leave there. So I set this cam up pretty fast, and it definitely had some bugs in it. It looks like it's not cutting to the edge, but that's actually just the modeled fillet. All right, you get the idea. There's the cutout parts. There's the scrap on the outside. It's very basic. So let's go to the CNC and cut this. First up here is the shear hog to face the top to get it nice and flat. If you're wondering how we're work holding this, we have a vacuum flow through table, so there's a big vacuum in the back room and it pulls through the top of the table through the MDF to our workpiece here. Well, that's an oddly ironic part of that song. Next up is the cove cutter. It's a 2-inch cove, which is essentially a ball mill, but you got to run that pretty slow, about 100 inches a minute. This is the Vortex 1440. It's the semi-roughing tool. It's an upcut 2-flute 1/2-inch diameter with chip breakers, so that just breaks up the chips a little bit better and is really great for roughing or slotting in hardwoods like this because you're generating quite a bit of heat in any slotting operation. I should have taken off the dust boot. You can't really see what's going on here. Sorry about that. Hold up, are you just watching this without subscribing? That'd be kind of rude. I joke, but I would love you to follow us. Smart move, past Justin. Take that boot off so we can see what's going on. You can see this 1440 just cuts really beautifully. Onto the outside profile cut with the same 1440. This is still a roughing pass. Listen to the change when we hit the end grain here. Without the chip breakers on the fluting, it would be much, much louder. And so that's really taking down the vibration, which makes for a better cut. And also it removes heat from the cut, like we talked about earlier, which helps extend tool life and you won't burn the tool or the material. It's just a lot better cut overall. The last thing that really helps with is it allows you to do a deeper cut because it reduces the strain on the spindle. So we did that whole 1.1 in just one pass. Now for the final operation, we're going to use the 3430, which is a 2-flute compression cutter with chip breakers. And that's going to do the final cleanup on the inside cord slots there and then the outside of the table to get a really nice finish. So there's an annoying bug in Fusion. When you do a ramp, sometimes it will extend the ramp for an incredibly long time. So that's what this is doing right now. It's ramping at probably like a degree or 2 degrees when I really want it to do 35 degrees. To fix that, you can change the max step down amount to 0, which is just really strange in the ramping or the last tab of the settings. This will look like there's two passes of the exact same thing, but actually I was doing a roughing pass, so it cuts all the way to the bottom, and then it steps in and cuts the whole thing at once to get a really nice spring pass finish cleanup. That's it for this part. I need a 3/4 inch sheet of scrap plywood to put down here, so let's go find that. Boy, that's a mess. Somewhere here. This'll do. It's just some AC plywood. We're just doing a quick 2D cutout with a couple holes, so this will go real quick. Something I love about working with digital fabrication tools is things just fit well, and I never really get tired of that. Now let's round over all the things with our 18-volt Makita trim router. Love these things, we have 2 of them. Sand this down to get a little bit of the tooling marks off the top. Wasn't looking for anything really high quality, but we start with 120 grit and move up to 180 and then 220. This is essentially perfect already. This compression cutter is absolutely spectacular. Just slight edge on that corner. Do a little 400. End grain that's that clean at the end. Whoo, baby. After vacuuming off the dust, I use a little bit of denatured alcohol and a clean rag to wipe off all the remaining dust before putting on finish. And now for a little finish, we typically use Osmo Polyex oil for pretty much everything in the shop. This is 3054, so it's clear satin, I believe. I'll put a link below. We found that if you use a foam roller, you can actually really optimize how much you're putting down. It's really consistent because you're ended up wiping it all up anyway, anything excess, but it's an awesome, really safe finish, and it looks really good on pretty much everything. It's also a perfect finish for this application where this top's probably going to get pretty abused, and Osmo, you can just essentially sand off wherever you need to, or literally just apply it right over old finish, and it will kind of patch itself without any weird sheen problems or issues otherwise. It's pretty great stuff. After putting on all I can with the foam roller, I get in the core drops with a rag here. So you can apply and wipe off Osmo in any direction. It doesn't really matter. It doesn't have a directionality. You won't see any streaks or marks afterwards. And the big key to a good Osmo finish is you wipe every bit of residue off so it's dry to the touch and not tacky at all. If it starts to get tacky on you, you've probably waited too long. I love Osmo because I am not a professional finisher and it looks wonderful even with my meager skills. It looks so good like this, I had to take some beauty shots before I continued on. Alright, that's enough. So easily the most awkward part of this project was taking the wheels off an already full tool cabinet. I probably could have taken everything out, probably would have been safer, maybe faster, but you know, you do it how you do it, and I decided I was going to take off the wheels while it was still full. I'm not proud of any of this. Watching this back, it's like a more safe version of doing an oil change with like a really crappy jack situation. Well, this side takes the cake. Just balance it on 3 scrap 2x6s, Justin. Now this, I have to say, was actually a pretty good move. I used some scrap strips of acetyl and some clamps to keep them in place so that I could slide the pretty heavy case across since it now doesn't have casters, as you saw. And that worked pretty good, but getting it in there, that's a whole nother story.
Perfect.
Got it. Hang on to the rail as I drunk camera you around to the back. I was excited. Give me a break. And that, my friends, is inertia. Thank God for gaffer's tape. Maniacal pandemic laugh, check. Stand up and knock over a light stand, check again. Well, okay, aside from that bumbling assembly part at the end, I'm actually really happy with this. It's turned out to be really helpful and we're all loving using it. It's nice to have a proper standing height table to work at to set up our tools. It also just looks nice, which is important to really have an appreciation for your workspace. If you'd like to get the Fusion CAD file for this, head over to our Patreon. There's a link below and a little bit more after this. If you want to support the channel but don't want a Patreon-like subscription, Buy Me a Coffee is the perfect option. The idea of Buy Me a Coffee is to offer someone a cash equivalent of buying them a drink as a thank you. It's a one-time thing to show your support for the channel and keeps the content and coffee flowing. Look for the link below for Buy Me a Coffee. If you want to get our CAD and CAM models that we show in the videos, subscribe to our Patreon at cnc.money. Thanks.